Hey guys, welcome to today's session on logistic regression. I'm super excited to have you all here because today we are diving into something that is absolutely crucial in the world of data science and machine learning. Today, we will look at logistic regression. To start with, let us understand what is logistic regression. What is the difference between linear regression versus logistic regression? What are the different types of logistic regression is there? What are the applications of logistic regression? Next, we will take a look at the mathematical foundation. Followed by that, we will explore how to train the model and how to evaluate the model using various performance metrics. All right, let's get straight to it. What is logistic regression? It is a machine learning algorithm, supervised machine learning algorithm used for classification problem. Unlike the linear regression, which predicts the continuous values, like predicting housing prices, logistic regression predicts the categories, like yes or no, spam, not spam, fraud, not fraud. Okay, so these are the the real life examples. Okay, the email spam detection. For example, you want to predict whether the given email is a spam or not spam. If it is a spam, it will flag that as a one. If it is a not spam, zero. In the case of medical diagnostics, does a patient have a disease or not? And also the credit card fraud detection. Is that a transaction fraudulent one or non-fraudulent? In short, right, if your task is to classify something into categories, then you can go for using the logistic regression. So that is your go-to algorithm in that kind of scenario. Okay. Next one is what is the difference between linear regression and logistic regression? Let's say you are a sales analyst. You are trying to predict the revenue based on the advertising spend. In that case, you would use linear regression because revenue is a continuous number, isn't it? What if I ask you, will increasing ad spend lead to sales? So in that case, right, here we are particular about the sales, right? How much money you have to spend in order to achieve my target sales or something like that. Right? So in that case, you are predicting the sales. So that is a continuous number. So in that case, a linear regression algorithm is used. So there are situations, right? We don't want a number. We need a category like a zero or one or yes or no, true or false. So this is where the logistic regression comes into picture. Okay. The key difference is linear regression, we use it for continuous values prediction, and logistic regression, we use it for classification, like spam or non-spam to predict that kind of thing, right? You can use that one. So now the question is, so why can't we use linear regression in place of logistic regression? Linear regression takes any value between minus infinity to plus infinity. If you make any prediction, right, it can predict the values anywhere between minus infinity to plus infinity. Whereas in the case of logistic regression, the target variable, for example, the is purchase, right? Purchase, not is purchase. For example, you want to predict what is the probability a customer can purchase given is so and so age. Okay. And also the target variable is it contains only 0 or 1, right? So here 0 and 1, you can see that if you plot all the zeros here. So here you can see that people with different age group, they did not, for example, in the case of churn, right? The customers did not churn. How many number of customers they did not churn, and how many number of customers are with us or, churn, right? Not, no churn, churn. How many number of customers they churned so far? When you draw a line here, right? When you draw, if you put a straight line in this case, what will happen is, and the predicted value and actual value, the distance between these two will be too high. Hence, the error will keep increase. This is violating your regression assumption, linear regression assumption. Okay, here it can lead to heteroscedasticity, and also if you plot the errors, it will not be normally distributed. It is clearly violating your linear regression assumption. Instead of using fitting the straight line, if you use something like a S curve, so if you draw a line which is closer to all the values, in the case of one, And if you draw a line which is closer to all the values of zero, and then if you join these two things, it will be S curve. It will be an S curve, right? Okay. For example, you want to predict the probability of a customer with age 30, 32, 48, 24. In that case, if you plug in the values in the equation, you will get the probability. For example, in this case, the intercept value is negative 1.87 and the slope is 0.076. And if the customer age is 32, so the probability is 0.56. So that means the customer with age 32, the probability of purchasing is just 0.56 only. And in the case of 48-year-old, if you plug in the value here, you can see that the probability of making a purchase from my in-store is 1.778, given that 48 years. But here the 1.778 is beyond my value 1. The probability value is anywhere between 0 and 1. It should not be above 1 or less than 0. Because we are predicting the probability using the logistic regression algorithm. So in this case, a 24-year-old customer, if you plug in this value, here we are getting the negative value. So there is a negative 0.046 probability of purchasing. We cannot say negative probability because the probability values lies between 0 and 1. Okay. Here, this one is correct. For the age 32, the probability shows just 0.60. But the remaining two scenarios, the probability, in this case, it is other extreme, right? So if the values are going above 1, these values are going below 0. Okay, these two issues needs to be addressed. So you need to bound these values, this value between 0 and 1. You need to bound these values between 0 and 1. So how do you do that? How do you do that? How do you do that? For example, right? So how do you convert the negative value into positive value? What are the possibilities that you can try to convert the negative to positive? You can multiply this with the same value, right? So 0.046, if you square this value, it will become positive because minus into minus, it will become positive. You square this value, it will become positive. And if you take the modulus on this, it will become positive. But what the scientists they did, right? So if you take an exponentiation of this one, it will become positive. Exp of this value, if you give that, it will give you a value anywhere between 0 and 1. Okay, it will bound this value anywhere between 0 and 1. Similarly, when you take an exponentiation of this, when you take an exponential of this one, it will. So in this case, yes, exponential is not required because only in the case of yes, Raghu, you cannot take. You don't have to take exponential. Anyhow, I'll come back here. Okay, you take this one, it will generate a value anywhere between 0 and 1 for this corresponding value. And for this one, how do we address this one? Okay, by taking exponential, we address this issue. How do you deal with this issue? In this case, if you divide this value, if you divide this value by the same value, and if you add 1 with it, it will become bounded between 0 and 1. This is how the scientists, they came up with the equation. So here, exp of this one and divided by 1 plus exp of this value, right? It will bound any value between 0 and 1. Even if it is a negative value or if it is above 1, it will bound all the values between 0 and 1. Or in the sense, it will generate a value to fall anywhere between 0 and 1, not beyond that. Anyhow, we will discuss this in detail in a little later. Next one is what are the different types of logistic regressions are available? The one is binary logistic regression, and then the next one is the multi-class logistic regression, and the third one is multinomial logistic regression. Okay, what is binary logistic regression? In the case of binary logistic regression, we are predicting the target feature or we are predicting the class label either yes or no. That is what your binary logistic regression. Multi-class logistic. In this case, the target categorical variable will contain more than two classes in it. So predicting one of the possible classes out of the multiple class, that is what your multi-class logistic regression. Okay, the next one is the multinomial logistic regression. It is similar to your multi-class, but it handles cases where outcomes are not mutually exclusive. Okay. For example, predicting a person's mood, something like happy, sad, or excited. So in this, multiple possible emissions are there, right? So in the case of binary logistic regression, so you are predicting either yes or no. Okay. Multi-class is for different categories, and the multinomial always the overlaps. Remember this. Okay, before we move ahead to understand the equation of the logistic regression, I just start with explaining you the basics of the probability and odds. Okay, we will just go over the basics because obviously understanding probability is central to your logistic regression. You will learn about what odds are and what the odds ratio is because again, that is central to understanding your logistic regression. Okay, I will briefly discuss how to interpret the odds ratio in logistic regression context. So the odds ratio is related to probability, of course. Okay, so what is a probability, guys? You might have studied in school time. So this is the equation for probability. See, the probability values are ranging between 0 and 1. This is the equation for probability. Okay, number of favorable outcomes divided total number of possible outcomes. Okay, so what is that total number of possible outcomes? For example, you are tossing a coin. What are the two possible outcomes here? Either you can get head or you can get a tail. Okay. So what is the probability that I can get head if you ask this question? So out of the two possible outcomes, there is a one probability or one favorable. Uh, you wanted to compute the probability of getting head, right? So in this case, the number of favorable outcome is 1 divided by 2. 1 by 2 is zero point 0.5. There is a zero point 0.5 probability that you can get head. That means the remaining zero point 0.5 probability you can get tail. Okay. So this is what probability. So probability is also called as the likelihood. What is the likelihood an event can happen? For example, if somebody tells what are the likelihood that I can get promotion in this appraisal cycle. Okay. Instead of quantifying that in terms of percentage, when it comes to statistics, we quantify the uncertainty using the probability. Okay. And also remember that the sum of the probabilities of all possible outcomes is 1. Okay. The sample space, there is something called sample space. It lists all possible outcomes. Next, we will jump into odds. What is odds? The probability of an event occurring divided by the probability of an event not occurring. That is what your odds. Okay. So we just this is how we define the odds. P over 1 minus P. The probability of an event occurring, that is your P. The probability of an event not occurring, that is your 1 minus P. See, the values of odds, remember that, okay, ranges from 0 to infinity. The values of probability ranges from 0 to 1. This is the one you need to remember it. Okay, I just give you a simple exercise. Can someone tell me what is the answer for this? I will give an answer for the first one. Here, let's say if the probability of winning 6 over 12, what are the odds of losing? Here, they given the winning, right? The probability of winning is here they've given the probability and they want you to give the answer in terms of odds of losing. Okay, what is 6 over 12? What is 12 here, first of all? Total possible outcome. Out of the total possible outcome, the probability of winning is 6. That means the remaining 6 is the probability of losing. Okay. So if the probability of winning, so if the question is something like what is the probability of losing? So the answer is simple and straightforward, 6 over 12. That means 1 by 2, which is a zero point 0.5. We can say that way. But if I have to tell it out in terms of odds, how do you do that? Odds of losing 6 over 12, right? How do you tell that? Sorry guys, I have problem with the Zoom. It got restarted. Okay. Now, what is the answer for the first question? Can someone explain or give me the answer for that? Okay, very good. One correct answer. Okay, one correct answer. Very good. Okay, so in this case, let's say, how do I solve this problem? So let's say the probability of winning is 6 out of 12, right? So probability of winning is equivalent to 6 over 12. And here it is going to be 1 over 2, right? So it is something like 0.5. There is a 0.5 probability of winning. That means if you play 12 times, you expect to win 6 times. Okay. So what about losing? The remaining 6 is you are losing, right? 6 out of 12, the 6 times I won. If somebody says that means 6 times they lost it, is it? Isn't it? So the probability of loss is equivalent to, you can say 1 minus 6 over 12. So in this case, it is going to be 6. This is 6, okay? 6 over 12. And again, it is going to be 1 by 2, which is 0.5. Correct? Is it clear? Okay. Priya has a question. Why do we need to subtract, 6 over 12 from 1? So what is 6 over 12 here? Probability of winning, right? If you subtract the probability of winning from 1, that is the one is your probability of losing. In simple term, if somebody says the probability of winning is 0.5, that means the remaining 0.5 probability that they are going to lose. That means how did you calculate? You're separating this one from 1. Okay, so 1 minus 6 over 12. And the 6 over 12 is the probability of winning. 1 minus probability of winning. In this case, 1 minus 6 over 12. And 6 by, this is nothing but 6 over 12 is equivalent to 1 by 2. If you solve this, you get 0.5. Okay. Okay, how do I, if I do 1 minus 6 over, how do I get 6 over 12? That's a basic math, right? So here, I just write it here. So here, how do you do this? So here 12, what is the common denominator? That is 12, right? So 12 into 1 is 12 minus 6, okay? And 12 minus 6 is 6 over 12. Is it clear? Okay, yes, yes, it's long time, right? Okay, agreed, agreed. Understood. Don't worry. Okay, now that we know the probability of loss, but the question is, what are the odds of losing here? Instead of saying probability of what is the chance of losing, we can also say how many losses compared to wins. How many losses compared to wins? Okay, so in that case, the odds, we are going to use the odds formula. We discussed a while back. Probability of losing in this case divided by the probability of winning. Because probability of, we need to compute losing, right? Probability of winning. Here, the odds of losing is 6 over 12. Losing is 6 over 12. Okay, 6 over 12. And then the probability of winning is 6 over 12. This 12 gets cancelled and 6 gets in. So 1 is to 1. Okay. So what does this say? 1 is to 1. For every one time I win, I also lose one time. Okay, this is called even odds or 1 is to 1 odds, which means winning and losing are equally likely. So what is the answer for what are the odds of losing in this case? It is 1 is to 1, which means for every one time I win, I lose one time. Okay, what is the, hope you understood, right? What is the answer for the second question? If the odds of winning are 13 is to 12, what is the probability of winning? This is pretty straightforward. If they ask you to answer it in probability, it's very simple, right? Okay, here the odds of winning are 13 is to 12. So in this case, pretty straightforward. You need to add these two values to get the total outcome. The case of probability, the denominator you need to put total possible outcome. Here the total possible outcome is 15. So how do I say total possible outcomes? You remember one thing very clearly. It's a quick tip, okay? So anything before the colon, in the case of odds, right? That is your winning, and anything after the colon is your losing. So total possibilities, possible outcomes are 13 plus 2, 15. What is the probability of winning in this case? 13. 13 divided by 15 is the probability of winning. Okay. Next question is if the odds of winning are 3 is to 8, what is the probability of losing? So 3 is winning and 8 is losing. So 8 divided by total possible outcome is 11. Okay. If the probability of losing is 6 over 8, what are the odds of winning? Probability of losing is 6 over 8. The probability of win. Now, that means the remaining 2 over 8, right? So 2 over 8. 2 over 8. So what are the chances of, what are the, how many winning compared to losses? We can say that, right? So in that case, what will happen? Yes, correct. What is the answer for this? I answered so far. It is now your time. You need to answer it. Okay. Tell me what is the answer for this. Okay. No worries. I will explain you this one. I'll give you some other exercise so that you can practice it. Okay. So instead of writing it straightforward, I know very well, right? Because out of total possible outcomes, there are 6 times I lost it. That means the remaining 2 times I won it. But mathematically, how do you do that? Probability of loss was given here, right? Here, if you subtract this from 1, you will get probability of winning. So 8 minus 6, 2 over 8, right? So here 1 by 4, 2 over 8, right? So which is nothing but 1 by 4, or we can say 2 over 8, right? So in this case, point to by something like that, okay? So what are the, now the question is, so what are the odds of winning? In this case, probability of winning, probability of losing. So in this case, 2 over 8 divided by 6 over 8. So 8, 8 get cancelled. You have 2 over 6, which is 1 by 3. Okay. That means the odds of winning is, odds of winning are 1 colon 1 is to 3. Every one time I win, I lose 3 times. Every one time I win, I lose 3 times. Okay. So if you play 4 times, if you play 4 games, okay, you expect to win once and lose 3 times. That is what it tells. So that's the key idea. Okay. Okay. What is next? Next, we will see the mathematical foundation.